Today, we're going to talk about how to graph a sine function, and we're going to focus on the amplitude and the period. We will not be talking about any vertical shift or horizontal shift in our graph at this time. So, what you are observing right now is an animation that was created by Desmos that shows you the relationship between the sine function and the unit circle. And since we've been talking about the unit circle for the previous couple weeks, I just wanted for you to be able to see it all in one place. So the sine graph is graphing the y values as we move around the unit circle. And when we complete one full unit circle, that is called a period. And you can see in this particular case, once we have completed the entire circle, the period for this graph is 2 pi. And then after 2 pi, the graph starts over. And it's going to continue infinitely on and on. This particular sine function is a positive version. If you had a negative at the front of your function, it would be a reflection of this graph. So now that you've seen this, I want to go ahead and move into some actual problems and talk about how to identify amplitude and period and how to write an equation and how to graph a sine function. So the first thing that I'd like to talk about is our formula for the sine function. Since we are not going to be shifting right, left, up, or down, our C and D values are actually 0 because there's no movement occurring here. And so we're going to use a simplified version of this function, focusing only on the amplitude, and then we'll use our period in order to find the B. So if you want to jot this down, our function will look like this, with just our A and our B being filled in as we determine our equations. So the A does stand for the amplitude, and when you think back to the graph that I showed you previously, the amplitude is actually going to measure between the center line and the top, the peaks, or the valleys of our sine function. So I'll show you that in just one second. Your period does measure when you have completed one full wave, which means that we have traveled around the unit circle one complete time. And we'll use this in these two equations, whether we're trying to find B, or we can use B when we're trying to find the period. So these are kind of our equations that we'll use throughout this activity. So down here, example 1, here I'm given a graph, and they've asked me to identify the amplitude and the period and then write an equation for this graph. So the first thing we want to do is identify the amplitude. And so if you can see that if I look at the top of my function, the highest number it goes to is a 4. And if I look at the bottom, the lowest it goes to is -4, which tells me that my center line here for this sine function does go through y equals 0 or the x-axis. So the amplitude actually measures how much above this center and how much below this center that I am drawing my graph. So I'm going 4 above and 4 below. So I can go ahead and write down that my amplitude is 4. One of the things to keep in mind when you're identifying your amplitude is that it will always be a positive number because it is a measurement. And so even though we can go down here, the measurement of the amplitude is still a 4, even though it is below the x-axis. All right, the period. So when we're talking about the period, we want to talk about how long it takes for us to make a complete wave. And a complete wave is going to have both the upward and the downward included in it. And so you can see, in order for me to finish out this complete wave, I traveled pi over 2. So the period for this is pi over 2. Now, in our equation, if you remember, we had to fill in an A and we had to fill in a B. And so we've got our A, sine, and then we have B, theta. All right, so our A is going to be 4. Whoops. But I have to find the B, and this is where we need the formula that I had a second ago. B is going to be equal to 2 pi divided by the period. Okay, so this time I have a fraction for my period, and so one of the things that you want to remember is that if you're taking a whole number and dividing by a fraction, you actually have to multiply by its reciprocal. So, in this case, the pi's are going to cancel, and the B will be 2 times 2, which is 4. And so that is my final equation for example 1. Now in example 2, we're asked, given the equation, to identify the amplitude and the period and the interval length, and then we're going to graph this sine function. I'm going to shift my page up a little so you can see the actual graph. So if you remember, the setup for my equation was y equals A sine and then B theta. All right, so the first thing that I'm supposed to identify is the amplitude. One of the things you want to be careful of is remembering that the amplitude is always a positive number. So I see this negative sign here. I need to think about, what does this negative actually tell me? The negative tells me that I'm going to do the reflection of the graph of 3 sine 2 theta. So my amplitude is 3, but when I graph this, I'm going to do the reflection. The next thing you're supposed to identify is the period. Now, if you remember, the equation gives me B, but it doesn't give me the period. So, how can I use B in order to find the period? Well, when we were trying to find B, we did 2 pi over the period. So I can actually reverse this around, and if I want to find the period, I will do 2 pi divided by B. So since they gave me the value of B is 2, then my period will be 2 pi divided by 2, which is pi. Now, I've got this graph, and I need to label what these tick marks are going to be. What is my measurement that I'm going to count by? And that's where that interval length comes into play. I know that the full interval requires me to do 1, 2, 3, 4 points to finish out the interval. And so if I take my period and divide by 4, then I will know what I need to count by. So I'm going to count by pi over 4. So this would be 1 pi over 4, and this would be 2 pi over 4, which does reduce to pi over 2. This would be 3 pi over 4. And then I have 4 pi over 4, which does reduce to pi. And 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, which is 2 pi. Now, these, my y is going to just count normally, 1, 2, 3, and then negative 1, negative 2, and negative 3. So now it's time to graph. Since I do not have any vertical or horizontal shift, I am going to start my graph at 0. I do want to focus on whether or not my first point is going to be above or is going to be below. A typical sine graph is going to go upward first, but because we are doing the reflection, we're going to go down first. How much are we going to go down? We're going to go down 3. So I will go down 3. I will always return back to the center, and now I'm going to go up 3, back to the center. This is one complete wave, which you can see here. My period is pi, meaning I should be able to complete one complete wave in that measurement. So now I'll continue. Down 3, center, up 3, center. And then as best as you can, draw a curve wave that goes through these points.